What is up, Flutter devs? In the previous video, we implemented the save capability in Flutter Processing. We ported that method from processing to Flutter Processing, and that allowed us to paint a single sketch to a file. But sometimes you want to capture a series of paintings in a series of files. For that, processing offers the saveFrame method. Today, we're going to implement that in Flutter Processing and round out our support for standard image saving capabilities in the processing APIs. Let's get into it. Here we are looking at the saveFrame documentation. And to quickly see how it's used in this first code example, you'll notice that saveFrame is called every time that draw is called. Now, one thing to note, this means you have to be really careful about creating an exit condition, some point in time where you stop writing to files. But every time this draw method runs, as long as x is less than 100, we save a new file. And that file has a different name as from the previous file, similar, but with a number incremented. In the next code example, it's almost the exact same thing, except now instead of using the default naming scheme, each file is called line dash, and then these hashes are replaced with a number, an index that counts up over time. Now let's read through what I just described to you to make sure I've got that right based on the docs. So when you call saveFrame, it saves a numbered sequence of images, one image each time the function is run, to save an image that is identical to the display window, if you want to save an image that is identical to the display window, run the function at the end of draw or within mouse and key events such as on mouse pressed, as mouse pressed, and key pressed. And then processing itself has this movie maker program thing that you can use to stitch it together. That's beyond the scope of anything that we're doing. If saveFrame is used without parameters, it will save files as screen-000.tiff, screen-0001.tiff. Now remember from the previous video, we don't support TIFF images yet. We may at some point. Our default is going to be PNG. You can specify the name of the sequence with the file name parameter, including hash marks, which will be replaced by the current frame count value. So that's actually interesting. I didn't realize that when I read this before. I always started at 0. The problem with using frame count is that it's going to be really easy to overwrite existing files. So I'm actually going to differentiate there. We are going to start at the lowest number that is not already taken up by some other file name. If you want to start back at 0, delete the files with conflicting names. Otherwise, we're going to start at the next available name. The number of hash marks is used to determine how many digits to include in the file names. Append a file extension to indicate the file format to be used, either TIFF, Targa, JPEG, or PNG. Image files are saved to the sketches folder. In our case, that's not true. The user is going to select a directory in our example app, and anybody who's using the Flutter Processing package is going to provide a directory reference. Alternatively, the files can be saved to any location on the computer by using an absolute file path. Again, not relevant to us. All images saved from the main drawing window will be opaque. I think that's true for us. I don't really care either way. So that's what we're going to be implementing. Let's go figure it out. Here's where we left off last time. We have this kind of hacking main file that's showing some images and setting some pixels and sampling some colors. And tapping on this floating action button allowed us to choose a file, a specific file, and then save a rasterized version of what we're seeing here to that file as one of those file formats. Today, we want the ability to save a series of files using the saveFrame. Let's start making those changes and see what happens. We'll keep the existing behavior that we implemented last time. So instead of calling saveImage, we're going to create a method called saveImageFrame. We're in the example app now, by the way. This is not the package. This is the example app. Here's the save image that we implemented before. We'll come down below it and create a method called saveImageFrame. Okay. In the previous example, or the previous use case, the user selected a file. We want a directory. Now, in my previous exploration of the file chooser, I didn't see an obvious way to select a directory. If it's there and you know what it is, put that down in the comments below. I couldn't find one, so instead, I'm going to let the user select a file, and then I'm just going to use the directory that holds the file that the user selected. Let's do that right now. So we'll say final file path equals await get save path. I'm not going to put any restrictions on the file type because we're not saving to that file, we're saving to the directory. Like previously, if the file path is null, print user canceled the file selection or return. Otherwise, we want to save the directory locally. Remember also from the previous video, we can't actually save the file in this function. What we do is we store the desire to save the files, and then the draw method actually does the saving because that's where the sketch is. We will create a local member called directory to save frames, and that's equal to the file the user chose dot parent, which is the directory. We also need to know how many frames we should save. Now, again, this is an example project, so you could make these decisions however you want. This is just how I'm choosing to do it in this example project. I don't want to risk accidentally letting this thing run forever. So I'm going to have a local member called remaining frames, and we're just going to set it to 20. We need 20. Let's go 10. Every time we do this, we will save 10 frames. Now let's declare those local members. A directory, which we said dir to save frames, and then integer, which is remaining frames. And actually that's not going to be optional. That's always going to be a number, 0 or higher. All right, with that, we now come down to the draw method. Here's where we were saving previously. That's never going to get triggered anymore because we switched what the floating action button does, but we can leave that logic, that's fine. We will say else if directory to save frames is not null and remaining frames is greater than 0, then we need to save frame, but we also need to say remaining frames minus equals 1, decrement that by 1. And now if remaining frames is 0, then directory to save frames, we're going to null that out. And what this line should read is we want s.saveFrame, and we're going to pass directory to save frames. Now remember, this doesn't exist yet. This is what we're implementing. And we will also add the ability to control the name, but let's get the default situation working first. So let's go implement this save frame. We'll come over to core. Here's save, which we implemented in the last video. Now let's implement save frame. I'm just going to copy this over because we're going to use some of it, and then we can delete the stuff we don't need. All right, save frame. We're going to take a directory this time, not a file. And we'll still take in the format for the same purpose, but we will also have a, what should we call this? We want the pattern to save the name. We'll call it naming pattern. And the default is screen dash hash 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 dot png. If no naming pattern is provided, we will call every file screen dash with 4 numbers after it. All right, so I copied this because we want this image format resolution. All of that still applies. We will want to generate the pixels, Actually, you know what? After this, we can just invoke the normal save method. So let's do this. Let's get rid of that. But one thing we do before we save the file, we need to figure out the naming. We have to actually name the thing. And we're going to need to do a little bit of regex for that. At least that's the best thing I could think of. If you can think of an easier way to apply that naming pattern, let me know down in the comments. We'll create a hash matcher, which will be a regular expression that looks for one or more hashes in the naming pattern. Has matches equals, hash matches equals hash matcher dot all matches, and we're going to pass in the naming pattern. So we're trying to figure out where those hashes are in the naming pattern. Now, if has matches is empty, do that again, hash matches is empty, then we're going to throw an exception. Naming pattern is missing a hash pattern. Else, if hash matches length is greater than 1, throw exception. Because if you have multiple groups of hashes, I don't know which one you want to use, and I'm not going to try to guess. You'll say naming pattern has too many hash patterns in it. There must be exactly one series of hashes in the pattern. Or more specifically, in naming pattern. Now, if we get past that if statement and the else if statement, then there is a pattern. There's exactly one group of hashes inside the name, in which case we need to know how many hashes there are because we need to pad the index. So we will say final digit count equals hash matches first.end minus hash matches first.start. The index at the end of the hashes minus the index of the start gives us the number of hashes. And now we need to actually figure out what to name this thing, and that includes finding an index that does not conflict with any existing file. We'll start at 0, because if 0 is available, that's the one we want. To check file availability, we need to actually instantiate a file. We need to do this at least one time, if not multiple times, to find a file name that works. So we will use a do while loop. The condition is, we will say while file exists sync. So we start going through all the files with these names. And as long as the file that we're looking for already exists, we need to increment the index to get a different file name. Final file name equals naming pattern dot replace all hash matcher. We will say index. So the index is 0, 1, 2, 3, etc. But we need to pad that. We need to pad left digit count with zeros. That's what's going to give us the leading zeros for smaller values. Then the file is file. Now we need the absolute path here. So I'm going to use multiple values in this string to build up the path to the file. We're going to start with the directory.path. Then we need a slash, or it really depends on your platform. So we're going to say platform.path separator, which is probably just a slash. And then we're going to say file name. Finally, we're going to say index plus equals 1, which only matters if we loop again. But what are we doing here? We're saying, hey, this is the file name we want to use. It is located here in the file system. And if it already exists, we're going to try again with an index that's 1 higher. So by the time we get out of this loop, we are referring to a file that does not yet exist, which means we have a file and we have an image format. And therefore, we can use our existing save method with the given file and the given image format. We don't have to replicate that behavior. We've already implemented it. Let's save that. All right. Still, so let's see, what are you complaining about here? File.path. Okay, fair enough. Cannot save image to, so this message should be different. Cannot save image to file. Okay, so what we're really comparing here is not file.path, it's naming pattern, because that has the extension that we are using for inference. All right, save that. Still complaining about something. Directory. And we know that it's not null. All right, save. Good. Now it's working. Let's come over here, tap this button. We get the file chooser as expected. I'm just going to save. It doesn't matter what we put up here for the name. I'm just going to save, and then this directory is where 10 files in sequence should be saved. Press save. Show a few. You see it's lagging because it was saving. Those are all saved. I can see them on the file system. I'm not going to share my file system, but I will show you some differences. Here's screen-0000. Okay? And let me see if I can find one that looks different. Well, the very next frame looks different. The very next frame shows the color sample. Let me find yet another different one. Here's the third one. Yet another different color sample. So you can see that we're capturing images as we go. Now it lags a lot. So this, if you're trying to do mouse work, cursor work, this isn't going to work because the processing time causes you to really lag in your frame rate. But if you want to capture some animations, this should be fine. Now let's try one other adjustment. Let's try a different naming pattern. Let's try test name underscore 2 hashes dot, this time JPG. So we're testing both the pattern and the file format inference. Save that. Come over here. Same thing. Save. Okay, I'm seeing them over here. I'll open up one of them. Here's test name underscore 00.jpg, and the file system is telling me this is a JPEG. So it looks like both the pattern and the extension inference are working. And so that's all it takes for us to now save sequences of images. Now, I'm pretty sure what I'm going to do eventually is come through here and add first-class support for saving GIFs, because I imagine that lots of people would like to do that. The P5.js implementation seems to include the ability to save GIFs. So I need to go find out what the situation is with saving GIFs in the processing API surface, but we might come back to that later. For now, these are the only two methods listed in the processing reference, save and saveFrame. We have implemented both of them, and they are now available to you to take snapshots of the cool things that you're creating. And if you do create anything and take a snapshot, I hope you will go share it on Twitter and tag me and let the broader community see what you're doing. With that, I'm not sure what we'll do in the next video, but I will see you whenever I figure out what that is.